Well, hello. We are almost done with this course. I'm really proud of everybody. Everyone's working really hard. This is the last section of notes that we're going to have. So keep working hard, folks. You're almost done. Okay, let's jump in here. We're going to be talking about probability and statistics this afternoon. And there's some vocab that we all need to be familiar with. The first one is the word experiment. An experiment is an activity where you can observe the outcomes. And you definitely want to highlight observable outcomes, because if you can't see it, then you can't observe it. So some examples would be like flipping a coin. You could get a heads or a tails, or rolling a dice. You could roll a dice, you could see what you get. If you have a spinner for like a game, you can spin the spinner and you can see where the spinner lands on. Those are all experiments. Now the word event is one or more of the possible outcomes of an experiment, okay? Webster's says any subset of possible outcomes. Now your sample space is when you write down all of your outcomes, and we're going to do that in a moment. So let's dive in here. If you roll a dice, you can get a 1, a 2, a 3, a 4, a 5, or a 6. Those are all the outcomes written down, so that's called our sample space. Now when you toss a coin, you've got two outcomes. You either have heads or tails. So these are the outcomes, but when they're written together, it's called the sample space. Now what we do in math to show a lot of our sample spaces, we make what's called a tree diagram. And let's pretend that we were going to toss a coin 4 times. And we want to write down all the possible outcomes. Well, first of all, on that first toss, you can get a heads or a tails. Okay? Now let's just cover the bottom part up. Let's pretend we tossed a coin and we got a head. Okay? Now we're going to toss it again. Well, now we can get a heads or a tails again. And then we're going to toss it again, where we could get a heads or a tails. Okay? So let's fill these in. So we could get heads, heads, heads. Okay, so right here. We could get heads, heads, tails. Okay? Etc. Or we could get heads, tails. Now we've got to fill in these. Okay? So you keep going. And here's all of your outcomes that are written down. Now what I want you to do on each, these are called branches, on each branch put a head and then a tail. So you're going to have a head and a tail. Right here a head and a tail, head and a tail, head and a tail, etc. Okay? And then to get your sample space, you just follow your branches. See, heads, heads, heads. All right? And then heads, heads, tails. That's how we're getting these. Okay, so right here now, this is our sample space. And we've got, let's count these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we say our sample space has 16 outcomes. Now let's do one of these together. Let's look at page 753, number 8. We're going to make a tree diagram. Okay, let's see here, number 8. Okay, it says, assume that it is equally likely for a child to be born a boy or a girl, and that the Lynn family is planning on having 3 children. What we're going to do, we're going to list the elements of the event that the Lynns have 2 boys and 1 girl. So let's make a tree diagram first. Okay, child 1. Here's our branches. They can have a boy or they can have a girl. All right, now let's pretend they have a boy first. Okay, now baby number 2 comes along. It can be a boy, or a girl. All right. Now maybe they had baby number 1 was a girl. Okay, then baby number 2 could be a boy or a girl. Now notice how my branches are connecting, and they were connecting over here. Make sure that your branches always connect. I've seen some really weird tree diagrams lately, so follow what I do, please. Okay, so this is child 1. These are our options for child 2. Now let's do child 3. So we have a boy and a girl. Right here we could have a boy or a girl. Here we could have a boy or a girl. And here we could have a boy or a girl. Now let's write down all of the sample space here. We could have a boy, boy, and then another boy. We could have a boy, boy, and then a girl. See how I'm just following my branches? Whoops. Okay, we could have a boy, girl, boy. We could have boy, girl, girl. Okay, now if we start off with a baby girl for child number 1, we'd have a girl, boy, boy. We could have girl, boy, girl. We could have girl, girl, boy. Or we could have girl, girl, girl. Okay, so here's our sample space. Okay, now it says, the question says, list the elements of the event that the Lynns have 2 boys and a girl. So 2 boys and a girl. Here we go. Oh, here's another one, 2 boys and a girl. And I think we've got it all. Okay. Might want to label these like this is child 3, this could be child 2, this could be child 1. Okay. Okay. Let's look at page 722 in your book. Let's do another one of these. We're going to do check your progress number 3. Okay, it says a die is tossed and then a coin is flipped. Find the sample space and determine the number of elements in the sample space. Okay, well, if you roll a dice, you could get a 1, a 2, a 3, a 4, a 5, or a 6. Now, let's pretend we roll a 1, and now we're going to flip a coin. Well, we could get a head or a tail. And here, if we roll a dice and we get a 2 first, and then we flip a coin, we could get a head and a tail. Heads and tails, heads and tails, heads and tails, heads and tails. Okay, notice again how my branches, they touch each other. They keep going. Okay, now let's write out our sample space. We could get a 1 and a head, or we could get a 1 and a tail, 2 and a head and 2 and a tails, 3 heads, 3 tails, 4 heads, 4 tails, 5 heads, 5 tails, 6 heads, 6 tails. So in our sample space, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We've got 12 outcomes. Okay, so here's one sample space, 12 outcomes. Okay, very nicely. Now I'll tell you what, sometimes you don't want to make tree diagrams because they get humongous. And let's look at a situation where we have to come up with a different plan. Okay, sometimes tree diagrams would be so huge that there's another way to find the number of outcomes. This is when we use the counting principle. We multiply our options. Now please underline this or highlight it. You're going to multiply your options. So it says, how many different sandwiches can we make with the following options? Okay, with our bread, we've got two options. We've got wheat and rye. With our meat option, we have ham, turkey, pepperoni, salami, and Spam. 1, 2, 3, 4, 5. Some people would say Spam is not a meat. My dad hates Spam. Veggies, we've got 3 types of veggies. We've got lettuce, we've got spinach, and we've got cucumbers. And for sauce, we have mayo. Now what you're going to do, you're simply going to multiply your options here. So 2 times 5 is 10. 10 times 3 is 30. 30 times 1 is 30. So we've got 30 different sandwiches. Now, here's the downside of the counting principle. We don't know what our sandwiches look like. Like over here, we knew what our outcomes look like. We wrote them down. Here, we don't have that. So if you want to know all the different types of sandwiches, then you'd have to make a tree diagram. But let me tell you, it's going to be huge, okay? Now what we're going to do is we're going to use the counting principle, which that just means that you're going to multiply your options with and without replacement. And I'll show you what that means. It says, how many different ways can the letters A, B, C, and D be arranged if they are only written down once? Okay, so we've got to put these letters in order. Now, how many letters do we have to choose from right now? Well, we've got 4. Okay, so let's say that I choose to put the C first, okay? So now that's gone. Now how many options can I pick for my second letter? Well, now I'm down to 3. Okay, so I decide that my second letter, I'm going to write an A. So now that's gone. Okay, now how many letters can I choose from for my third letter? Well, I only have 2 left, and I think I'm going to write the letter B down. Now that's gone, so I only have 1 letter left. And again now, we're going to multiply these together. 4 times 3 is 12, 12 times 2 is 24, 24 times 1 is 24. Okay, let's try this again. Okay, we've got the letters A, B, C, and D are on cards now. Okay, so maybe you even want to draw a little picture here. Here's some cards. Okay, now we're going to pick up a letter, and then we're going to put it back. We're going to replace it. We're going to do this 3 times. How many different combinations can you have? So let's see here. Okay, I want you to pick a card. How many choices do you have? Well, you've got 4, right? So I'm going to pick the B card, okay? So I had 4 choices for my pick number 1. And now I'm going to replace it, so I'm putting it back in the list. Okay, so I've got 4 letters again to pick from. So for my second pick, again, I have 4 options. So I'm going to pick a D. So I pick it up, I look at it, and then I put it back. Okay, I'm replacing it. So now I'm going to pick my third card. Well, how many choices do I have? I still have 4, don't I? Okay, so 4 times 4 times 4 is 64. Okay, next problem. The numbers 0 through 9 can be used for a lock combination, which contains 4 different numbers. So let's label these. This will be number 1. This will be number 2, number 3, and number 4. Okay. How many combinations can there be if the numbers cannot repeat? Cannot repeat. Okay, well, first of all, let's write down all of our options. We've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we're coming up with this combination lock, and for our first number, let's pick the number 5, okay? But how many choices did we have? Well, we had let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got 10 numbers to choose from, okay? And I'll tell you what, let's say we're going to use the number 5. So now that's gone because it says the numbers cannot repeat. Okay, now our second number, how many choices do we have? Well, now we have 9 choices. Okay, let's say we pick the number 2, so now that's gone. All right, now we're going to pick our third number. Now how many choices do you have? We've got 8. Let's say we choose a 0 for that third number, so now that's gone. And then we have a 7. Multiply those together, and we get 5,040. Now let's do the same problem over again where they can repeat, okay? Now I've kind of run out of room, so I'm going to draw a little arrow down here. So for our first number, let's pretend now these aren't crossed out. We had 10 numbers to choose from, and they can repeat, so we're not going to cross anything out now. So our second number, we have 10 numbers again. Our third number, we had 10 numbers again, and our fourth number, we had 10 numbers again. So if they can repeat, we had 10,000 options, okay? Alrighty. Now the next section we're going to talk about are probability and odds, and I will tell you, people use these words interchangeably all the time, and they're not interchangeable. So please be careful. Before we start, I wanted to let you know that there's some good practice problems. If you go to this website right here, then you go to lessons and then probability theory. So you might want to go here and check it out. Okay, the probability, it's the measure of the likelihood that a given event will occur. Okay, that's the probability. So the probability, let's say, of my birthday occurring again, I was born in 1966. Is that going to happen again, 1966? No, not going to happen. So I would say the probability of my birthday in 1966 happening again is 0 or 0%. Okay? What's the probability that tomorrow's going to be here? Tomorrow's definitely going to be here. I mean, I might not be here tomorrow, but tomorrow will be here. So the probability of tomorrow being here is 1 or we say 100%. Okay? P stands for probability. What you're talking about goes inside of parentheses. Okay, now probability is expressed as a number between 0 and 1 or in percents from 0% to 100%, and I would highlight that. Now we write probabilities like this. We put the letter P and then E stands for the event. So on the previous page the event was my birthday. Okay? Now you got to be careful. People want to confuse this with function notation all the time, and don't do that. Be careful. Okay, so if an event must occur, the probability is 1 or 100%, or if it's not going to happen, the probability is 0 or 0%. Now to find probabilities, we're going to set up a fraction, okay? Let's say you flip a coin. What's the probability of getting a head? Okay, now, so the probability of getting a heads is the head we're talking about, so that's 1, but how many elements are in the sample space of flipping a coin? Well, you can get a heads or a tails, right? So our denominator is going to be 2, but there's only one way we can get a head, so 1 out of 2 is our probability. Okay, or if you want to write that as a percent, we would say 50%. Okay, let's look at this next one. When you roll a die, what's the probability of getting a 3? Well, there's only one 3 on a dice, right? Out of how many? Out of 6. Okay, now if you're a percent person, you can change this. 1/6 is 1 divided by 6. Multiply by that by 100 and you get 17%. Now if you're a decimal person, you could write this answer as a decimal also. Okay, that's fine with me. Let's go back to the dice here. When you roll a die, what's the probability that you're going to get an odd number? Let's think about this. You can get a 1, you can get a 3, or you can get a 5. So those are 3 options out of 6. 3 out of 6, make sure you reduce that to 1/2. And then again, 1/2 is 50%. Okay, let's try this one. When you roll a die, what's the probability that your outcomes are going to be less than 8? Well, let's see. 1 is less than 8, 2 is less than 8, 3 is less than 8, 4, 5, 6. They're all less than 8. So 6 out of 6 are all less than 8. Okay, so our probability is 1 or 100%. Now let's think about a deck of cards. There are 52 cards in a deck, and I want to know what's the probability of picking a red queen. Okay, now how many red queens are there? Think about that. You've got your queen of diamonds, and you've got your queen of hearts. So that's 2 out of 52, which is 1 out of 26. Now again, if you'd like to change that to a percent, you go right ahead. That's fine with me. What about the probability you're going to get a jack? Now it doesn't say anything about the color. So how many jacks do we have? Well, we have 4 out of 52, and that reduces to 1 out of 13. And you have to reduce, folks. Okay, what's the probability of getting a black card? Well, black cards are either clubs or they're spades. There's 13 of each, so that would be 26 out of 52, which would be half of our deck. Okay, what's the probability of getting a green club? Have you ever seen a green club before? Neither have I. 0 or 0%. Now let's look at our book. Let's do a problem there. Let's look at page 754. And we are going to do number 42. Okay, it says a card is selected at random from a standard deck of playing cards. Compute the probability that the card is a face card and that it can be a jack, a queen, or a king. Okay, now think about how many face cards you've got. Okay, so think about that. You've got 4 jacks, 4 queens, 4 kings. So that's 12 out of 52. There we go. If you want to put that as a percent, here you go. It's about 23%. Okay, let's turn the page to 753. We're going to do problem number 12. Okay. We're going to switch gears here again. It says, compute the probability that the Lynns will have 2 boys and 1 girl. Okay, let's go back to our tree diagram right here. Okay, now we had 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have 8 outcomes. And let's see here, they wanted 2 boys and 1 girl. 2 boys and 1 girl. Okay, 2 boys and 1 girl. Well, we've got 3 out of how many? 3 out of 8. There we go. That's our probability. Okay. Okay, next problem. We are going to look at rolling 2 dice, okay? And we're going to find some probabilities. Now, first of all, notice something here. There's some patterns. We're going to use inductive reasoning right now. Look at this diagonal. These are all the doubles, okay? Now, if you look at this diagonal, our pips, by the way, pips are the dots on die. Here our pips add up to 3. Here on this diagonal, our pips add up to 4. Here our pips add up to 5. So we've got just some patterns here that I want you to be aware of. Okay, we're going to look at this chart, and it's going to help us answer some questions. Actually, let's just write ourselves a note here. There are 36 outcomes in our sample space. Okay, it says, this is all probabilities. What's the probability that the sum of the pips, now there's your black dots, the sum of the pips will equal 8? Okay, well, let's look for a diagonal that they equal 8. Here we go. 6 plus 2 is 8, 5 plus 3 is 8, 4 plus 4 is 8, etc. So we've got 1, 2, 3, 4, 5. Okay, 5 out of what? 5 out of 36. Okay, let's try the next one. The sum of the pips is at least 10. So our sum could be 10, it could be 11, or it could be 12. Okay, so let's take a peek here. Right here, this diagonal, the sums equal 10. And right here, the sums equal 11. And right here, they equal 12. So we had 1, 2, 3, 4, 5, 6. Okay, we had 6 out of 36, and please reduce that. Okay. To reduce, we divided our numerator and denominator both by 6. Okay, now let's find the probability that only one die shows a 4. Only one die shows a 4. Okay, so let's go back here. Let's see, there's 1 4 here, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, now some of you might say, hey, wait a second, you didn't count 4 and 4. Well, that has 2 dice that show a 4, so I can't count that. So we had 10 out of 36, which reduces to 5 over 18. Again, if you want to change that to a percent, go right ahead. That's fine with me. Okay, each die will be odd. Okay, each die will be odd. Okay, so let's see here. Each die will be odd. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, only 9. 9 out of 36, which is 1/4. Okay, now we're going to do one in the book, page 754. It talks about the doubles. It's problem number 38. Now it says, if 2 dice are rolled, compute the probability of not rolling doubles. Not rolling doubles. Okay, well, let's see here. Let's look at our doubles first. Here are all the doubles, right? Now we have 1, 2, 3, 4, 5, 6 that are doubles. So 36 minus 6 is 30. So 30 out of 36 are not doubles. Okay. Okay, we are almost done with today's video. We're going to do a few more here. Now we've got some marbles here. 1 marble is drawn at random from a bag. Now this bag has 4 white marbles, 6 red ones, and a green one. Okay, now let's count up how many marbles we've got. We've got 4 plus 6 is 10. 10 plus 1 is 11. Okay, so we've got 11 marbles to deal with. We want the probability we're going to get a white one. Well, we've got 4 whites. 4 whites out of how many? Out of 11. Okay, now red or green. We've got 6 here, 1 here, so that would be 7. 7 out of how many? 7 out of 11. Okay, what's the probability that we're going to draw a purple one? Well, how many purples do we have? We don't have any. So 0 divided by 11 is 0. Okay, that is the conclusion of the first video here. I do want you to make sure that you're reading your text. Please add some notes right here about empirical probability, and that's found on page 747 of your notes. Okay, thank you for watching. Bye-bye.